Welcome back. Let's read a bit more about good passengers aircraft. It's 12 soon 1 p.m. I need to get too much sunlight. I need to close it. So let's read about Boeing 777 yesterday, but we have a 77X. Let's read about it. It's 12:20 a.m. And I could read about the Boeing 747 jumbo jets. Many of these old, they're still flying, even they're not make it anymore. They have stopped production many years ago. They're not scrapping like this one. It's still flying all over the world, like freighters, and even this 757. The President Donald Trump used it as private aircrafts. Donald Trump, and they still use the jumbo jet. The Boeing 7 is still use it because you're not scrapping old aircraft like old cars. And they still, I think Lufthansa still use this. They use it to Germany, to United States. But let's read 77X. I need a minute. I was supposed to make some video in English about it, but I just do in my language, Danish now. So I need some kind of done for today. I just like to reading this Boeing 77X and the jumbo jet. Need to check my cell phone again. So let's read this and charge my camcorder and upload.
Boeing 777X. The Boeing 777X is the latest series of the long-range, wide-body, twin-engine jetliners in the Boeing 777 family from Boeing commercial airplanes. The changes for 777X include General Electric GE9X engines, composite wings with folding wingtips, greater cabin width and seating capacity, and technologies from the Boeing 787. The 777X was launched in November 2013 with two variants, the 777-8 and the 777-9. The 777-8 provides seating for 395 passengers and has a range of 8,745 mi, 16,196 kilometers, 10,064 mi, while the 777-9 has seating for 426 passengers and a range of over 7,285 mi, 13,492 kilometers, 8,383 mi. The 777X program was proposed in the early 2010s with assembly at the Boeing Everett factory and the wings built at a new adjacent building. As of September 2024, there are 503 total orders for the 777X passenger and freighter versions from 13 identified customers and unnamed buyers. The 777-9 first flew on the 25th of January 2020. Deliveries have been delayed multiple times. As of October 2024, Boeing expects the first aircraft to be delivered in 2026. To the launch customer Qatar Airways. Development, edit. Initial design, edit. In 2011, Boeing refined its response to the revamped Airbus A350XWB with three 777X models, targeting a firm configuration in 2015, flying in late 2017 or 2018, and entering service by 2019. The then proposed 407-passenger 777-9X stretched the 777-300 by 4 frames to 250 feet 11 in, 76.48 m, in length, for a 759,000 pound, 344 t, maximum takeoff weight, MTO. It would have been powered by 99,500 lbf. 443 kN engines, targeting perceived 21% better fuel burn and 16% better operating cost. Early designs of the smaller 353-seat 777-8X proposed stretching the 777-200 by 10 frames to a length of 228 feet 2 in, 69.55 m. with a 694,000 pound, 315 t, MTO and 88,000 lbf, 390 kN, turbofans to compete with the A350-900. An 8LX version with the 9XS MTO would have had a range of 9,418 mi, 17,560 kilometers, 10,910 mi. The current 777-200LR /300 has a 775,000 pound, 352 t, MTO. The proposals also included a carbon fiber reinforced polymer, CFRP, wing with a wingspan of 213 or 225 feet, 2,560 or 2,700 in, 65 or 68.6 m, with blended winglets, or up to 233 feet 5 in, 71.1 m, with raked wingtip would have provided for a 10% larger wing area. The aircraft would have fallen into ICAO aerodrome code F like the 747-8 and a 380 but with 22 feet 6 in, 6.9 m. Folding wingtips would stay within the 213 feet 4 in, 65.02 m, code E like current 777s. Horizontal stabilizers also were extended. Engine selection, edit. The General Electric GE90-115B of the earlier 777-200LR and -300R variants has a 40:1 overall pressure ratio and 23:1 HP compressor ratio. Rolls-Royce plc proposed its RB3025 concept with a 132 in, 335 centimeters. Fan diameter, a 12:1 bypass ratio, and a 62:1 overall pressure ratio, targeting a fuel burn of more than 10% lower than the GE90-115B and 15% lower than its Trent 800, powering the 777. The RB3025 concept has a composite fan, a core derived from the Trent 1000, and advanced HP materials. Pratt & Whitney responded with the 100,000 lbf, 440 kN, thrust PW1000G geared turbofan architecture. GE Aviation proposed the GE9X with a 128 in, 325 centimeters, diameter fan, a 10:1 bypass ratio, a 61 overall pressure ratio, and 27:1 HP compressor ratio for a 10% fuel burn reduction. In March 2013, Boeing selected the GE9X with a 132 in, 335 centimeters, fan. It is the largest fan made by GE. In the rest of 2013, thrust was bumped to 102,000 and 105,000 lbf, 450 and 470 kN, to support the motor growing from 769,413 to 775,000 pound, 349,000 to 351,534 kilograms, and increasing the payload range, with a possible 108,000 lbf, 480 kN, envisioned. Some customers bemoaned the loss of engine competition, like Air Lease Corporation CEO Stephen Udvar-Hazy, who wanted a choice of engines. Airbus points out that handling more than one engine type adds millions of dollars to an airliner cost. Pratt & Whitney said, engines are no longer commodities, the optimization of the engine and the aircraft becomes more relevant. Launch, edit. In 2012, with the Boeing 737 MAX in development and the 787-10 launch in preparation, Boeing decided to slow 777X development to reduce the risk, with introduction still forecast for 2019. On the 1st of May, 2013, Boeing's board of directors approved selling the 353-seat 777-8LX to replace the 777-300 from 2021, after the larger 406-seat -9X. The design work is distributed between Charleston, Huntsville, Long Beach, Philadelphia, and St. Louis in the U.S. and Moscow, Russia. Its development cost could be over $5 billion, with at least $2 billion for the carbon composite wing. On the 18th of September, 2013, Lufthansa became its launch customer by selecting 34 Boeing 777-9X airliners, along with 25 Airbus A350-900s to replace its 22 747-400s and 48 A340-300/600s for its long-haul fleet. At the November 2013 Dubai Air Show, the -8X for 350 passengers over a 9,300 mi, 17,200 kilometers, 10,700 mi, range, and the -9X, seating more than 400 over 8,200 mi, 15,200 kilometers, 9,400 mi, were launched with 259 orders and commitments for $95 billion, $123 billion in 2023, at list prices. This was the largest commercial aircraft launch by dollar value, with Emirates ordering 150, Qatar Airways 50, and Etihad Airways 25. In addition to the September 2013 Lufthansa commitment for 34 aircraft. Boeing dropped the variant's X suffix, while keeping the 777X program name at the 2015 Dubai Air Show. In June 2017, Lufthansa was considering delaying 777X deliveries and could limit its -9 orders to 20 and order more A350s. Due to its large order, Emirates will become the first operator instead of Lufthansa. Production, edit. In December 2014, Boeing began construction on a 367,000 square feet, 34,100 m, composites facility in St. Louis to be completed in 2016, to build 777X parts with 6 autoclaves for the wing and empennage parts, starting in 2017. The 787 surge line at the Everett factory would be converted into a 777X early production line by the end of 2015. Boeing built a 1,300,000 square feet, 120,000 m, building adjacent to the Everett factory, with a 120 feet, 37M, autoclave, and a robot to wind fiber for the wings. The first 777X was planned to be built on the X787 surge line. The -9 firm configuration was reached in August 2015, and assembly of the initial aircraft was to begin in 2017 for a December 2019 introduction, advanced from the previously scheduled 2020. With a current 777 production rate of 100 per year, 380 on order at the end of 2013 and no orders at the February 2014 Singapore Air Show, bridging the gap to the 777X deliveries starting from 2020 is a challenge. To stimulate orders, sales of current 777S can be paired with 777Xs, and used 777S can be converted to freighters to be sold and stimulate sales. 2017, edit. In April 2017, the initial one-piece wing spar came onto the assembly jig and was about to enter layup in June. First parts assembly for the initial -9, a static test airframe, were underway in the purpose-built wing center near Everett, Washington. 4-9S, a fatigue test airframe, and 2-8S were planned for testing. Tests of avionics, power and integrated systems continue in Boeing field laboratories and were integrated into an Airplane Zero in 2017. A 70% detailed design was done by June 2017. The assembly of the first composite wing test example began in Everett in late September 2017, with its top section lowered into a jig for robotic drilling. Boeing launched the 777-9 production on the 23rd of October with the wing spar drilling. Its maiden flight was scheduled in the first quarter of 2019, 1 year before its introduction, perhaps with Emirates. On November the 7th, 90% of the engineering drawings were released, with the airframe before the systems. 99% of the wing and 98% of the fuselage drawings are released. The detailed design phase was expected to be completed in 2017 as avionics, power and other systems are ready for ground tests. Aircraft numbers 1 and 6 were planned to be used for ground tests. 4777-9S, number 2 to 5. Were slated for the flight test and certification campaign, with 2777-8S to come later. Final assembly was planned to start in 2018 before rollout the same year. The 777X production techniques were expected to be major cost cutters. The fuselage automated upright build, FOB, system was developed and quietly tested in Anacortes, Washington, 40 miles north of the 777 Everett assembly plant. A major leap in automated production, it drills the tens of thousands of holes in the fuselage more quickly, accurately, and safely. The wings are the first produced by Boeing in composite and not outsourced like for the 787, and production is largely automated as well. The specifically built billion-dollar factory has excess capacity, laying the foundation for the company's expected future programs. The new midsize airplane, NMA, and later the new small airplane to replace the 737. 2018, edit. In February 2018, Subaru, ex-Fuji Heavy Industries, completed the first aluminum and titanium center wing box integrated with main landing gear wheel wells at its Handa factory. The factory was completed in April 2016 and started operation in 2017. It has 125,000 square feet, 11,600 m, of floor space and is equipped with automatic riveters, transfer, and painting machines. Boeing's first composite wing spars, stringers, and skin panels are formed in the $1 billion composite wing center before assembly on a new horizontal build line. In February 2018, its wing components were ready to go through assembly as Mitsubishi Heavy Industries, the 787 composite wings manufacturer, advised Boeing on the wing assembly. At this time, 93–95% of the design was released, complete for structures and in progress for systems and engine installation before interiors. Fuselage sub-assemblies started shipping on February the 7th, aft fuselage panels from Mitsubishi Heavy Industries, center and forward fuselage panels from Kawasaki Heavy Industries and the 11 forward/45 center wing box from Subaru. In March, fuselage assembly was to begin in Everett at a temporary production line between the current 747-8 and 777 assembly lines to avoid disrupting the 777-300 production. The static airframe and the first flight test aircraft bodies were to be joined in the second quarter of 2018 and in June-July, respectively. Scheduled for the start of 2018, the GE9X first flight has been delayed by the variable stator vane actuator arms redesign, but the slip should not change the engine certification schedule or the first flight of the 777X. The flight test engines were to be shipped later in 2018, before the year-end rollout and first flight expected in February 2019. During the component development, 2 temporary engines were to be placed on the first flight test aircraft. Wing assembly is difficult, with the light but strong carbon fiber material being less forgiving than traditional aluminum, and aircraft systems integration in a special demonstration lab is not as quick as planned. The first 777-9 fuselage assembly started in March 2018. In May 2018, Qatar Airways head Akbar Al-Baker thought development was a couple of months late but expects Boeing to catch up, provided no certification issues arise. To avoid disrupting current 777 assembly, a temporary low-rate assembly line was set up for up to 38 airframes before transitioning to the main FAL in the early 2020s. The first -9 rollout is due in late 2018 and all 4-9 prototypes are to join the flight tests by mid-2019, while the 2-8 prototypes were to be assembled in 2020 before deliveries. The first wing was completed in May for static tests before the flight test wings. By July 2018, 98% of its engineering had been released. By September, the static test 777X article was completed, lacking engines and various systems, ahead of its structural testing on ground. The first join on the static test aircraft was done in 16 days instead of the planned 20, and lessons learned from the 787 wing body join led to a single defect instead of the hundreds usual in new models. The final body join of the first flight test aircraft was completed by November, before an early 2019 rollout and a second quarter first flight. By late 2019, it should be joined in the flight program by the other 4 777-9 prototypes which were undergoing assembly. The first flight test aircraft was built 20% faster than the static airframe. At the end of November, the electric systems were powered on and the rollout was expected for February 2019. First deliveries are planned for May 2020, while the first production wing spar was going to be loaded in early December. To position wings and fuselage sections, automated guided vehicles are replacing overhead cranes and monuments, large, permanent tooling fixtures. The primary systems were installed by December and its second GE9X engine were to be hung in early 2019. 2019, edit. Engines were installed by early January 2019. The first 777-9 body join happened in February for a delivery planned in summer 2020 to Lufthansa. The rollout of the prototype occurred on the 13th of March 2019, in a low-key employees-only event overshadowed by the crash of an Ethiopian Airlines 737 MAX 8 on the 10th of March. The GE9X engines installed on the 777X prototype were first run on the 29th of May. However, a compressor anomaly occurred with another engine during pre-delivery tests, and the maiden flight previously planned for no earlier than the 26th of June was delayed while the engines are modified to a final certifiable configuration. As of the 17th of June, 2019, GE expressed confidence that the engine would receive certification during the fall and that the first flight of the 777X would still occur in 2019. The 777X test plan was later revised as several months are required to develop and test fixes to the GE9X, and first flight slipped to October-November. By June, the first prototype began low-speed taxi tests. On the 24th of July, Boeing announced that the GE9X engine issue would delay the maiden flight until 2020. The company continued to target first deliveries in 2020, though it intends to boost production of current generation 777 freighters in 2020. GE Aviation in Ohio is recalling 4 GE9X turbofans from Boeing in Washington state in Antonov 124 freighters from Volga-Dnepr Airlines, mounted in 26x14x13 feet, 8x4x4M, 36,000 pound, 16.3 t, stunts. On September the 5th, in the presence of FAA inspectors, a door blew off on the 777X static test airframe during the ultimate load test, which is conducted with the airplane stressed and pressurized beyond normal operating limits. Depending on the outcome of its root cause investigation, Boeing should have time to modify the failed part and repeat the test during the margin from the existing engine-related delays. At 99% of ultimate load, 1.48 times the limit load, the aluminum skin ruptured under the center fuselage, aft of the wing, and the damaged structure extended up the fuselage side to a passenger plug door which blew out and not an outward hinged cargo door. In October 2019, the JITA board created to review the Boeing 737 MAX certification noted that the FAA would need to assess more thoroughly how modifications interact with the aircraft. The FAA did not announce how its review and certification of the 777X may be affected. The 777X was already a year behind schedule as service introduction was targeted for 2022, a further delay due to the certification as a derivative could risk key orders. Boeing received the first flight-compliant GE9X on the 18th of October with a second engine due by the end of the month, for a mid-November power-up. On the 13th of November, the FOB robotic system was abandoned after 6 years of implementation, to use human machinists more. By mid-November, a pair of flight-compliant engines were installed on the first 777-9. 2020, edit. As part of an investigation by the FAA into the fatal crashes of the Boeing 737 MAX aircraft, emails were released that showed that a problematic supplier of parts for the 737 MAX flight simulators was still being used for 777X simulators, on an even more aggressive schedule. Boeing stated that the 777X does not have an equivalent of the Maneuvering Characteristics Augmentation System, MCAS, that is installed on the 737 MAX and that played a role in 2 crashes. Testing, edit. The first test flight took place on the 25th of January, 2020, at 10:09 a.m. from Payne Field in Everett, and ended in Boeing Field in Seattle after 3 hours and 52 minutes. The second 777X first flew on the 30th of April, by which point the